Welcome back to my shop. This summer's project has been a fun yet challenging one. If you're here for laser cutting, you're in luck. I think this project encompassed almost every machine in my workshop. Fiber laser cutting, engraving, bending, welding, some 3D printing, CO2 laser cutting, maybe even a little lathe work and CNC milling. Yeah, so let's go. Surely this has happened to you also. Late night perusing a Facebook marketplace and, oh, this is interesting. And look, it even works! And the next day I'm driving 3 hours to go pick up a piece of garbage to satisfy my curiosity. Lucky for me, the seller didn't nearly convey the amount of rust and damage this unit has, so there's going to be a lot of work ahead of us. I'm not really interested in the projection TV or the controller part of it because I want to convert it and run it off of my PC, but I plug it in just to confirm my suspicion that this thing's dead. And I was right. It's not worth my time or energy to start diagnosing what all's wrong with this, so let's start disassembling. I grab some WD-40 and a screwdriver and start taking off all the plastic body panels. From there, I move on to take off the seat assembly. The graphics on these side panels are going to get destroyed whenever I clean up all the rust, so I take some clear photos in case I ever want to create the graphics down the road. I continue stripping this thing down to the bones. My pile of removed parts continues to grow while I uncover the extent of this rust damage. I get the pedal assembly removed, and now I think I'm ready to try to separate this upper portion from the base. I'm not sure how it's all connected, so we'll start by removing a couple of these. The top and bottoms are separated now. I just need the engine hoist to help me lift this off there. Alright, with the top removed, I can start taking off the hardware off the base and get it ready to clean up this rust. A few more parts added to my pile. And now the base is ready to be cleaned up. I will spare you all the grinding footage, but I was out here for hours cleaning this up. I also used the angle grinder to cut off this piece that used to be used to attach the coin collecting unit. At this point, I'm still unsure on how I want to try to do the force feedback on the steering wheel, so I pay special close attention to how this is all assembled before I start taking everything apart. I get the entire steering assembly removed, and then I go through and remove all of the wiring. Next, I remove the seat mount and slider assembly. The seat adjustment slider was rusted tight, so I had to order a new one to replace it with. Now with everything removed, I get to spend several more hours grinding off all the rust. I get all the parts cleaned up with mineral spirits, and then get everything spray painted. It's not perfect, but it certainly looks way better than before. After the paint dries, I get it back inside and start reassembling the seat. It looks much better and the new seat slider works. I clean off some rust off the front speaker grills and then get those repainted. Those look much better, so I can start reinstalling the dashboard. I did a quick sand and paint of the steering column and a deep clean of the steering wheel, and now I can get that all reinstalled. I sanded and painted this arm that holds the shifter, and I'm getting that reinstalled, and it's starting to look like a car again. Now let's start having some fun. The pedals. They feel really good. The gas feels good, and I really like how the brake feels. It provides like a really nice amount of resistance. But they're disgusting, so before I do anything, I'm going to take this all apart and clean it up. One cool thing about this car is that it has two base shakers. One on this plate behind the pedals and then another one behind the seat. I get these pedals cleaned up and replace a couple of the potentiometers. There's just one problem. I grew up driving a stick shift and not having a clutch is just not an option. So I grinded off this footrest plate and I bought an identical set of pedals off of eBay. I think I'm going to cut off the brake pedal and modify it and use it as my clutch. I think that's going to work. Now I just need to clean up this plate that they're all attached to. I get that all cleaned up and painted, and also a few other panels I need. Alright, that looks pretty good. Now I just need to modify the cover plates for it so I can get everything reinstalled. Alright, the pedals are finished and installed back in the car, and I think they turned out pretty nice. It almost looks like it was made that way. I am so sick of cleaning up all this rust. Only a few more panels before I can get to the fun stuff. I get all these decals removed. More grinding and painting. I get them reinstalled. And I do a quick test fit with all the plastic body panels so I can see how it's all gonna look. The weather's been rainy all week, so I haven't been able to finish grinding off this platform. So I take a break and start ordering components. I get this little 2-channel amp to power the bass shakers, and then I get this 5.1 channel amp to drive the speakers and subwoofer. I find this 50-inch monitor and stand on Facebook Marketplace for super cheap, so I picked that up to use for the screen. I get the STM32 Discovery board and a 1 kilowatt AC servo motor for the force feedback, and then I get the Arduino Uno, a couple 100 amp power supplies, and 43 amp motor drivers for the motion system, and then the Arduino Leonardo is just for some buttons. Then I get these 2 DC motors to drive the motion system. I think they're rated at 50 nanometers. All the links to all these components will be in the description. I temporarily mount everything to this board so I can start doing some wiring and testing of all the components. I have a couple potentiometers to track the position of the DC motors for the motion. So in Fusion 360 I quickly model up these couplers and a way to mount them to the motor for testing purposes. I get those parts 3D printed and mounted to the motors. To drive the motion system, I'm using this SMC3 software found on the xsimulator.net website. This website has been a huge resource for this project. I get everything wired up and I have the software running, and it looks like the motors are working. The motion is going to be one of the last things I try to implement, so I'm going to set this aside for now and move on to the shifter. The original shifter only has 4 speeds, or 3 in reverse if you set it up that way, which is just going to be inadequate for most games. So I found this shifter online that can do 7 speeds and reverse, and it looks like it may just fit in the original location. And I got this more comfortable knob. It looks like it's going to just fit if I remove those 2 mounting tabs from the bottom and then create a new plate so I can mount it the way the original did from the top. I start getting it all disassembled so I can get this bottom plate free to cut off those sides. Looking back on this footage, I don't know why I chose to put this in the vise vertically instead of horizontally, but anyhow, I plowed my way through it and now the sides are gone. I created a quick mounting plate based on the original design, and I cut that out of 1/4 inch MDF on the CO2 laser. I get that mounted and it looks like it's gonna work. It feels nice and solid, but I noticed that the plastic cover is restricting the movement on the side, so I'm gonna have to enlarge that hole a little bit. But I'll do that in a minute because I also need to cut another hole in here. I want to add a second panel of buttons. Buttons 1 through 4 are labeled on the dash, so I'll start the numbering here with 5. I grab a sheet of stainless steel and I get that cut out on the fiber laser using nitrogen as the assist gas so it'll leave a nice clean edge. Alright, that looks pretty nice. I think I want to put these buttons somewhere right about here. I head over to the fiber laser engraver and get the file all set up and get the button panel aligned and ready to engrave some numbers. I install some buttons and it looks pretty good. Now I just need a hole. I wanted to throw this on the CO2 laser, but I'm not sure what kind of plastic it is, so I opted to just use a Dremel to cut this out. And it looks like we have a nice fit. I get the buttons all wired up, and you could see where I did my test engrave on the back side of this panel before I did the final on the front. I prepare some wires to run it down to the Arduino. I get everything plugged in and secured, and then I get it plugged into the Arduino. The shifter boot that I bought was binding and tearing, so I removed it, and I modeled this piece and 3D printed it out of a flexible TPU filament. And here's the end result. I think it turned out pretty nice. So I found this great tutorial on hackaday.io on how to use this MMOS software to do the force feedback. For the life of me, I could not get it to work with the Servo motor and driver that I bought. So I returned it and bought this MIDGE 130ST servo motor with an AASD driver off AliExpress. I was able to wire up this one and get it to work with the software no problem. So now I just needed to find a way to mount this huge motor. So I head back over to Fusion 360 and design this motor mount to be cut out of a 1/4 inch steel plate. I have it set up to run all of the piercing operations first, and then we'll come back and cut out all the pieces. I forgot to change the focus of the laser head for doing this piercing operation, so it didn't quite punch all the way through. So you'll see while it's cutting, it throws an error a couple of times as the laser nozzle comes into contact with the molten metal on top. I forgot to mention it, but during that operation I also cut out this little plate that's gonna mount to the steering wheel drive shaft. I'm gonna turn down a new shaft that's gonna attach to the motor, then the plate will connect to this existing plate, and I'll weld the shaft and that plate together. Then I'll attach it to the motor shaft with this coupler. Alright, all the pieces turned out nice, and now it's time to learn how to weld. I picked up this cheap flux core welder, and I did a test on a piece of scrap, so I guess I'm ready to let it rip. Well, it didn't turn out horrible for my first try. It did come out a square a little bit when it warped, but I think it'll be fine whenever I bolt it down. So I'm gonna get it painted up here and ready to mount. Because of the change in plans of using this larger motor, I'm gonna need to cut a hole in this panel so it will actually fit. So angle grinder to the rescue. Alright, I got the hole cut and I put on some rubber edge trim so there's no sharp edges. Now I need to drill some holes to mount the plate. I get everything loosely into position so I can see how long I need to make this shaft. I cut a piece of round bar roughly to length. I head over to the lathe and bring it down to a couple different diameters. And here's what we have. Now I need to try my hand at welding again and attach these two together. Alright, that turned out much better than my first attempt. Everything seems to fit and line up properly, so now I just need to bolt the two together. Alright, direct drive force feedback motor installed. Now we can move on to some more fun stuff. During all of my testing, I'm already sick and tired of wrestling the mouse and keyboard around every time. So I bought this little handheld keyboard with a trackpad, and then I designed and 3D printed this little mount so I can have it accessible on the dashboard. I got that mounted, and you can see I've also added a couple toggle switches, and I had to replace all of the buttons on the other side. It turned out 3 out of 5 of them were not working. I get all of the dash buttons wired, and I mount my 2 Arduinos up here close, so I just have 2 USB cords coming down. I couldn't really move the project forward without it, so I finally broke down and finished all the grinding and painting of this base. It turned out okay. I get this hardware reinstalled that allows the upper section to pivot on its one axis. The motion system is only going to have a roll motion from side to side. I attempted to fabricate a mounting point that would allow 2 axes of freedom using a U-joint, but this thing is so heavy I just don't trust that it's going to carry the weight, so I ended up scrapping it. Now for the fun part. I get the engine hoist back out to help me lift that top section up so I could get it on the base. It was a struggle, but I eventually got it there. I get it all bolted on, and then I can get the seat reattached. I get the body panels back on, and now we're back in business. Finally, I'm on the last piece to get cleaned up. I wasn't crazy about the original gray color, so I paint it black instead. I let it dry and get it reinstalled. And yeah, I'm real happy I went with the black. I like how this turned out. I didn't want to mess with the original fluorescent tube, so I ordered this RGB LED light bar to install instead. The original piece of acrylic that goes here was all busted up, so I've designed a new one. But the large thick acrylic's kind of expensive, so cut out a template here to make sure my design's accurate and all the holes line up before I cut the real piece. And it looks pretty good. So I head over to the CO2 laser to cut out this acrylic panel. Alright, let's check out how it looks. Alright, looks like it's pretty good. Let me get this cleaned up for install. Okay, I got it all cleaned up, and it looks like it's gonna fit. Cool. I turned off the lights here so it's easier to see how the acrylic glows in the LED light. Alright, the eye candy's done, so let's move on. So the car has these 2 front speakers and 2 rear speakers in the seats. But it needs a subwoofer. I was going to do an external subwoofer, but then I learned about these under seat subwoofers, so I'm going to try to take that and mount it right under here in the back. Alright, I got the sub hooked up, and I think it's going to be perfect to round out the sound for those 4 speakers. So I just need to get it mounted up underneath there. Cool, that'll save me so much space. Alright, so I need to start figuring out how this motion system's going to work. So I designed these motor mounts in Fusion 360. I'm going to cut these out of 1/4 inch plate again, and I just did all the piercing operations, and now it's going to cut. Alright, those turned out pretty nice, so I'll get them cleaned up and painted. And then I can get them bolted to the motors. I have to drill a few holes and then I can get them mounted in place. Now that I've cleaned up the mess from drilling, I make this board to permanently mount the electronics. There's a nice little recess under here. I want to make this removable, so if I ever need to work on anything, I can pull everything out. Alright, I've got everything mounted to the board and wired up. This is just the electronics for the motion system. Now I can slide it back into place. Next, I design and 3D print this little mount for the bass shaker amp, then I get both the amps mounted. I'm really working hard to find spots for all these components. I want to try to get everything contained within the machine. So I find a spot to mount the servo driver and the controller here in the back. As I'm thinking through how to design the lever arms and linkages for these motors, I realized I overlooked a much better way to mount these. I realized they'd have much better mechanical advantage if I mount them over to the sides rather than in the center, and I think I just found a spot where they'll fit. And the motor mounts will still work, I just need to modify them slightly. So, angle grinder to the rescue. I get them reattached and I feel much better about moving forward with this design. I have a total of 7 different USB cables coming from all the different controllers, so I mount a USB hub up here on the front. Next, I design these lever arms that'll attach to the motor shafts in Fusion 360. I have this 1.5" round bar stock on hand that I want to use, so I spend an eternity cutting a chunk off here to size to mill. I start milling this down to size, and then it hits me. I've way overcomplicated this, and I just thought of a much easier solution. This perforated square tube already has all the features I need. I just need to cut them to length and enlarge a couple holes. So I get out this step drill bit, enlarge a couple holes, and these parts are ready to go in a few minutes. I guess I just got caught up in the excitement of getting to use one of my machines and overlooked the simple solution. Then I cut down some slightly larger square perforated tube to act as a mounting point on the base. I cut a couple rods to length. Then I tap both the ends to accept the rod end bearing joints. Then I fit it all together to see if it's actually going to work how I imagined. Most of the force on these arms is going to be on the holes where the pin goes through the motor shaft. So I decided to weld a stack of washers on each side to provide some extra reinforcement. I'm using stainless steel washers, and I turn down this pin to keep everything aligned while I weld them. They're not exactly pretty, but at least there's some extra meat on there. The through holes on the motor shafts are a really odd diameter, and I couldn't find any standard hardware that would fit snugly. I want it to be a very tight fit so there's no slop in the system. So I'm turning down a couple double-sided bolts to use there. Okay, those are done, so now I'm just going to manually thread the ends. Next, I designed some mounts for the potentiometers. I really enjoy using the sheet metal tools in Fusion 360, how it allows it to unwrap and then you have your flat pattern for laser cutting. I cut these out of 16 gauge steel using nitrogen as the assist gas. I get these bent into shape real quick. Alright, they're ready to install. I get them bolted on and the potentiometers hooked up. Alright, I finished setting it up in the software. Now the final thing is to add my double-sided bolts and then we can test this out. So the good news is mechanically it seems to work, but almost immediately one of the cheap motor drivers burn out. So I'm going to move on for a second while I order some and wait for those to arrive. So it turns out on this monitor stand that I bought, the wheelbase is slightly too narrow to be able to slide it up close to the machine. So I'm just going to take the monitor and lose the stand. Since I'm trying to learn how to weld, I went and bought some square tube and I'm going to see if I can fabricate my own stand. I went out and bought a cheap welding table so I could have some hope that this thing would turn out close to square. Alright, it's mounted. Looks pretty good. Alright, more motor drivers have arrived so I can do some more testing of the motion system. I keep blowing these 43 amp motor drivers, so I'm going to replace it with this 2x60 amp or Sabertooth 2x60, which is 60 amps per channel, and we'll see if that solves the problem. Alright, this Sabertooth motor driver works great. The motors run much quieter and it has no problems with overheating. The motion is super jerky as I'm just manually jogging it back and forth, but I'll later learn how to configure that and smooth it out using Simtools. Finally, I can get the rest of these body panels back on. The Sabertooth motor driver calls for a battery to be wired in parallel to absorb the regenerative current from the motor driver. So I install a car battery and a disconnect switch. Next, I add some cross braces to my monitor stand to add some stability and keep it from rocking from side to side. Alright, I'm getting down to the finishing touches. I 3D print a cup holder and get that installed. I replaced the grip tape that was on the floor so it's not slippery when you get in and out. The original seat cushion was trash, so I find these soft floor mats that have this nice checkerboard pattern, so I think I can cut them down and make a new seat cushion. I line the entire surface with carpet tape and mounting tape around the edges. I think it turned out really nice, much better than I was expecting. Just when I thought I was done, I noticed that the monitor would sometimes flash in the middle from the jerkiness of the motion system. So I decided to make some floating spring mounts to absorb some of that impact. So back to Fusion 360 sheet metal tools. I get those laser cut and bent, and then I add some springs and some foam. I get them mounted to the monitor, and they work. No more screen flashing. Alright, I'm calling this project complete. It's been a challenging but a fun one. I had a blast making all the laser cut parts and finally starting to learn how to weld. I think in the future I'll probably avoid any project that requires this much rust removal. I hope you enjoyed watching my journey. Stay tuned, I've got another project on the way. Hopefully it'll be out soon. And a special thank you to all my Patreon supporters who make these kinds of projects possible. Thank you.